Thanks for tuning in today, whether or not it's your morning, afternoon, or evening. It's my Friday morning, my time, about 6 o'clock. So thank you for coming to the presentation today. We'll be talking about things related to Power Query, some performance optimization, and otherwise just kind of best practices and tips and tricks and things related to the to-dos, the not to-dos, and kind of what to look for when working towards more optimized queries that will both run faster but also be easier to manage, and a few other stuff related to this today. So what I want to do from my perspective, and okay, no, I don't know how those controls. I want to talk about a little bit of who I am, give you a bit of background about myself, and then for the next hour or so go through some of those practices that I mentioned in Power Query as well. So my name is Reid Havens. I've been in the BI space for nearly a decade now. I do a lot of stuff related to design and aesthetics, but I started all the way back with Power Pivot and Power View, for those of you who remember that way back in the day. In Microsoft Excel, kind of the grandfather of Power BI, and as the industry evolved, slowly moved with it. And these days I do a mixture of remote development and consulting for a lot of my clients. I actually teach at a few different universities as well, so a local college here in Seattle, Washington, and Washington State. I'm a data visualization instructor as well, and I found a lot of passion in kind of finding a nice crossroads between design and also the science that goes into visualization as well. Making sure that the numbers are right, that the charts are displaying the information correctly, but also applying a little bit of artistic polish and aesthetic design that goes with those things. So kind of a nice little happy medium that I fall into it. Today's session will be definitely more of a technical session, as I mentioned, with performance and tuning. But as a MVP and an end-to-end developer, it's a skill set within the Power BI umbrella that I have many different tools when it comes to pretty much building out a report for a lot of clients. So we'll be spending a lot of time on that today. It'll be pretty much demo driven, but there will be a little bit of slides and some concepts and introductory things that we'll go over here at the beginning before we actually get into the demo. So let's talk a little bit about the theory and some of the principles in Power Query as well, now that we've had a chance to have a bit of an introduction. What I do want to do is, if I can, there we go. Just want to make sure that my chat is up over on the right, so if anybody ever has any questions, I can see it. Okay, perfect. So yeah, this will be kind of the flow that we'll be going over today. We'll kind of have 4 primary sections that we'll be discussing. The first one's going to be about reducing data, eventually moving in, and let me get there we go, my laser pointer, optimizing query performance, talking about leveraging query folding, which is a very useful and powerful feature inside of Power BI. And then finally, with time permitting, we'll also get a chance to potentially talk about how to handle some conversion errors and utilize a technique that I came across from another Power Query MVP that will hopefully prove very useful to you as well. All right, so let's start the conversation with discussion around reducing query data. All right, so in terms of reducing query data, the general idea behind this, and the 2 primary common reduction transformations are column modification and reducing rows. The goal with this, to think about it, is in Power BI, you can import data. You import multiple tables into your model, and with every table that you import, whether or not it's a dimension table, whether or not it is a fact table, the goal for all of these imports is the fact that you want to be able, you don't want to pull in a single column or a single row more than what you actually need for the report. I see a lot of people who just connect to a table in SQL, import it, and then they bring on someone like me and they're asking like, hey, why is my file like over a gigabyte? It's can't fit under the Power BI service. I'm getting errors, I'm getting performance issues, and it's, well, you're importing a 60 million row fact table and you have about 85 columns that you are importing with this, and then wondering why it's about 1.8 gigabytes to add this to the file. And I take a look, and then I determine at some point that you're using about 8 of these columns, and based off of the filters that I see in your report, you probably only need about 8 million of these 50 million rows that need to be in your model. So it is very important usually to do one of these 2. And we'll walk through what type of ways that you can modify your columns and reduce your rows. But that's the general concept, is you should not import any more data today than you need. It's easy to make these changes in the future, add data in, make modifications to your transformations, but really you should be servicing the report today, not a report that is maybe in a theoretical report in 6 to 12 months that might need that data. You build for today and maybe for the near future, but the far future can be edited down the road. Okay, so column modifications. The beautiful thing with Power Query, and for those of you who have used it before, understand that it is a WYSIWYG type of device, and that is an acronym, at least in English, that refers to what you see is what you get, and it's the initials of each one of those. It comes out to a funny sounding word. It's one of my favorite things in the industry just because it has a little bit of fun to it, but it also just implies that you can give an action to Power Query. You click a button, you tell it to remove columns, it writes the script for you. So it's a very intuitive system in that, and it's easy to learn because you really don't have to learn much code with Power Query. Once you have the business logic, you tell it, hey, do this, and it does the hard work for you. But between some of these steps here, there's also an idea that not all transformations are created equal. In this case, removing columns actually has a different effect than choosing, depending on how your data grows in the future. And we will talk about these considerations during the demo, but with a lot of the stuff that I like to try to push off as best practices to people, I try to recommend actions and commands, transformations that are going to be in your Power Query steps that are going to be more dynamic than fixed, because you don't want to have to come in and make edits in the future. You don't want things to break, certainly, but you want the whatever transformations you've done to ideally shift and work with changes in your data. You want it to work nicely or play nicely in those environments. So I will talk through considerations about this and hopefully allow you to kind of take away some best practices related to this stuff as well. And there's also, on top of being able to simply remove or choose which columns you want to import, there are many, many different ways to transform the columns as well. And this can come into the idea of like splitting a column up as needed. There are certain performance considerations to choosing the data types and potentially changing the data type from text to numbers if you are able to modify the data within a column as well. So there are a couple of transformations and techniques, takeaways that I will again mention during the demo section related to transforming the data within the columns that will again work towards kind of reducing the file size, optimizing the model, and essentially working from there. But this just kind of highlights, at least on the ribbon, all the many different art of possible options that you have available if you are wanting to do like column transformations. Now we've talked about column, at least from a high level, the different ways to interact with those. Now we can also go into here and discuss the various options for reducing the rows. So we've discussed the ways to reduce the width or columns. Now we're going to discuss the ways to reduce the height, which will in this case be the rows. So filtering rows is probably the most common. Typically that either is by category or date. So filtering off of product ID, category name, something to reduce that. And very commonly, most fact or data table queries that you have usually will have a couple filters onto there. Unless you're doing like a company-wide report, generally if you're within a department or a org, a section of the company, it's going to be a filter on there somewhere to filter down the global data to whatever that report happens to be servicing. And with both text and date filters, there are ways to do dynamic or intelligent filters as well that we'll also see here in a little bit. Another common one as well for types of ways to get rid of unnecessary extra rows is removing empty. Now, there are times where if you're pulling data from like a database, let's say you have 85 columns. There might be situations where for certain rows in those 85 columns, there might be only a few columns that actually have data in it. By the time you've removed most of the columns you don't need, there sometimes has been occurrences and can be occurrences where basically the columns that you have left could actually have entirely blank rows that still need to be removed. It's not adding much to the file size to import blank rows, but it does sometimes add interesting complexities to the relationships or other considerations to have. So they have a nice feature in here that just automatically scans the table design that you've configured, and if there are empty rows, it automatically just scrubs them out to remove the need to have to accommodate for those once you're in the model itself. Same thing with duplicates. As part of the process as you're potentially creating your own dimension tables or other things that you're doing to need to shape the data into a certain structure, it has an easy option to remove duplicates, which will once again reduce the number of rows available, but also work towards a better model structure. And by the way, these are a kind of an introduction of just the art of possible of ways to reduce rows. So that way, once we actually do the demo, it will make a little bit of sense of some of the actions that I'm doing. One of the last ones that we'll talk about here is removing errors. Now, this one is something that the very last section of the demos today, time permitting, removing errors can be really useful if the situation calls for it, because there's one unique type of failure that Power Query can have. So most often, if something really does break, a column gets renamed in the database, you do a transformation on that column, that query can no longer process because it's looking for a column that can't be found. Occasionally, though, you get a change type error. So let's say you are importing from an Excel file, you have 500,000 rows. Maybe like 20 or 30 of those rows, for the date column, somebody put the letter A character in one of the date fields, because most of us who worked with Excel have seen times where bad data gets accidentally entered into the Excel file. So it will still load with an error message. It's one of the few types of breakages that can happen in Power Query, and the actual data will still load, but a few rows will have an error, basically a little bit of error in one of the columns. And at that point, we will discuss later, you as the developer can choose to either fix the errors or you can remove the rows with the errors. So it really does depend on how you want to accommodate for that. We'll address all of that later. But one of those options is simply just automatically scrubbing any errors that are being imported right out of the import, so you don't have to even worry about them. But we'll discuss both considerations and which is best for your business scenario if you encounter those. And then the final one really is the group by. So it allows you to summarize data up. And this is another good example where you're technically not filtering the data, but you are reducing the granularity. So I'll give one example for this. Let's consider product information. If you have a report that the lowest level that you are reporting on or displaying is product subcategory, you might not necessarily need the data broken out in your fact table down at the product name level. So you can group by and summarize the data up. So you can take your 500,000 rows at the product name level, and you can use the group by function to summarize it to maybe product subcategory ID. So you've now gone from, say, 500,000 rows to potentially 350,000 rows. You reduce the granularity, so it's less rows to process. The file will be smaller, the calculations will run faster, and you are not putting in any data that is at a lower level that needs to be displayed in or calculated in the report level. So that's another consideration to have if you are running into issues with too many rows. Each of these we'll see demonstrations on how to do, but this is a nice series of slides which will be available for download later if you'd like, that just talks about the art of possible, so you can get a framework before we actually dig into the demo itself. Okay, so let's go ahead now that we've discussed the column and row reduction scenarios, and I'll open my demo file and go through a few of these scenarios in person with you guys. All right. I'm just getting my screen right up. Okay. Excellent. So we're going to start with a sales query table, and I'm going to slowly kind of walk through a lot of the items that we can discuss in here. Now, one of the things that I want to start with, let's see, do a quick refresh to this to see if I can get my column distribution. Okay, so the fun part is sometimes Power Query doesn't always work as well as I would like it to. So normally, this is what I would expect to see is Power Query has a great feature called column distribution, but sometimes it's a little buggy. So as a pro tip, 3 things that I recommend to turn on in Power Query whenever you are using it for helping you identify patterns, trends, and quality in your columns. The quality, distribution, and profile. These are all 3 really useful things because it gives you, in this case, it shows you actually the number of unique values, how many are distinct, many different kind of qualifiers, whether or not there's any errors. And for some odd reason on, there we go, on my actual working file, they're not showing there. But what I will mention to you because I can't show it to you visually, is that the column distribution for my sales key is a 1-to-1. And yeah, turning it back on doesn't do anything. Okay, so the sales key itself is a great common scenario that I see people as a pain point. They import this in, and it is a 1-to-1 relationship with the rows. So every row has a unique sales key or row key, row identifier. And I've had a scenario where I've been brought in by a client where they had like a 3 GB file about an 80 million row fact table that was in there, and they had a row order key that was in their fact table. And my first question is, all right, so this is 1-to-1. There's no need to count it because every row is a unique identifier, and each row represents an order in this case for them. So like, what's the goal of this? Oh, well, we do a count on this column to determine like order count. Okay, so row count will do that for you without the need for the key. Do you display this key anywhere? And they said no. So I quite honestly went in, I deleted this column, I refreshed the model, and I went from 3.8 gigabytes to about 700 megabytes in the matter of 3 to 4 minutes it took to save the file. It was a snap of a finger, and it got rid of a large portion of it. I can actually even show you over here a great example of what that looks like. So there we go. Let's do this. This column removed before and after this sales key, it has this file size that I have right here. And that is one of the most common perpetrators. And one of the, again, most common pain points that I see people experience is they import a high cardinality column, which means it has a lot of unique values, and they very often do not need it. So if it is not being used in a key as a relationship in your model, if it is not being used in any way to display on a visual, meaning there's no visual that is displaying sales key, I'm not drilling into sales key, then very often you can use a count rows function in DAX to get the number of these, because each row already is an identifier for however many orders by date, by category, etc. So keep in mind, do I need any type of row identifier key? Because those will kill the file size in your model and double, triple, or quadruple the amount of memory is required to store it. Because at the back end for Power BI, and I'll summarize it very quickly, it is a compressed engine, which is called a tabular engine, and that compresses data by column. So the less unique values there are, basically the more repeating values there are, the better it can compress. It has a great little algorithm of a bunch of techniques to save repeating values, understand the row that it was located on, and then deduplicate the data and basically allow the file to shrink from a much larger, like let's say Excel file that you pulled the data from, into a file that might be like 1/30th the size in Power BI. But when you have a lot of unique values, it can't really do much for compression. So those should be gone as much as possible. So that will be our first step that we're going to do. Now I could come here and I could simply just say remove column. Now I would consider this to be probably not the optimal way to do this. So if I did this, and one other thing that I'll mention to turn on, keep the formula bar on, because this tells you what the logic is doing. So it gives you an indication of what's happening. Now, let's assume this is a SQL table. In the future, if I connect to this and some new column shows up that I don't need in my model, it's going to automatically get imported, because I am only doing 3 steps. I am connecting to a source, I'm navigating to the name of this instance, this table as an example, and I'm removing one column specifically called sales key. So if any other columns come in the future, they automatically get included with my import. Now, if I want to safely box in this data and not add new columns unless I choose to, that is where choose columns comes in. It has the same effect as removing the sales key column today, but it accommodates for the future to make sure that I don't accidentally import any additional columns that would come through. So let me show you that. Coming back to here, and by the way, I got rid of my remove column step by clicking the X button. So choosing columns, same thing. I'm just getting rid of one column, but I want you to observe now the code here at the top. So now what I actually have is I have a body of code that is selecting all of these. So these have been selected, which means it is hard-coded to only ever importing these columns unless I come back to this query and I edit this in the future at some point. There we go. I can come back into here very easily. I can make a change if needed, and boom, I can immediately have my new data. But now it's my choice. It's not going to come in and by its own, and this prevents unnecessary data imports from additional columns that you might not want. So that's kind of one best practice that I would recommend is, and you can kind of see how two actions have the exact same effect, but which will change better with your data in the future. And there are many instances of this in Power Query where you have maybe one or two different ways to do something, and you have to think about how is the logic working? What is the code being read into here? Is it removing a column? Is it selecting a column? And just consider both and make a business choice if you can find two solutions for this. Okay, so that's kind of number one. Another one that we can go through is the idea of data types, which is very important. So there are a couple ways to kind of go through and clean this. A quick and easy way, just as an FYI, to apply data type to everything, and especially when connecting to an Excel source. There is no defined data types in Excel. They do need to be specified in here. So I could just do Control A, and I can select everything, and then I can come up to Transform, and I can do Detect Data Type, and that will automatically detect the types for all of the items that we have into here. Now, one thing that I will mention as a precaution is be careful of setting the data type for too many things that are going to be a text field. In this case, most of our stuff's pretty good, but I will kind of mention as a pro tip that anytime you see, there we go, anytime you see ABC123, might remind you of a Michael Jackson song, but what it also indicates is that it's a generic data type. And if I just loaded the model, if I just loaded the table as is, like you see here, that will automatically get converted to text. So if there is a column that needs to be a text output, I would rather not actually define the data type as text for that. Just as there's a term, at least in English, called Murphy's Law. If it can break, it will break. So I generally try to keep my code as simple as possible, because the moment that I have a column that is referenced in here, so let me break something for you to show you. Any of these can break. If I have these columns that have their type changed, if they change in the data source, this step will break and I have to come and fix it. So let's just show an example. Let's assume that unit price tomorrow, somebody rename that in Excel to this one. There we go. And it is now renamed there, but this has now broken. So my recommendation then is, if there is ever a point where I'm just going to get rid of this. If you're doing a change type, I'd honestly ignore the ones that are going to be text fields. They don't need to have a data type set because they will automatically be assigned a text field as soon as that happens, and you'll be good to go. So that's kind of one little pro tip to simplify the code up here to make sure enforce that happens. All of these you want. Channel key should be a number. Date key should be a number as well. And kind of down the line with unit cost as being a decimal number. So those need to be set as that, because at some point you need to aggregate those. So they do need to be converted to certain ones. Now, the one that I want to call out here is product key. So this is a text type at the moment, and in order of like least to most efficient for storage, you would have your text, your date, and then your numbers. So ideally, if you can set things away from text, if possible, usually a good thing to work towards a slightly smaller column as far as the storage goes. And we can take a look, and we notice that product essentially has PD and then a number. So we could probably actually extract the PD from here, take it out, change this to a number, and then we have a number data type product key. Granted, we would have to do this on both our fact table and our product table, but it would at least still clean up the data and work towards a more optimized model just a little bit. So let's go ahead and do that. I'm going to do that before the change type step. So I'm going to come back to remove other columns, and we're going to insert a new step right there. That is going to sandwich it between these other two. I'm going to come up to product key, and we are going, where are we at? Replace values. Insert. Here, actually, I'm realizing, one quick sec. My dimmer is on. There it is. Okay. I have a screen dimmer that I was realizing was darkening my screen just a little bit, so I'll lighten it up. I'm going to look for PD. Now the trick is with replace is technically replace values can also be a remove values. All I have to do is don't give it an alternative result. Don't let it specify anything. There are a few advanced options I'm here where you can actually choose to match entire cell contents, replace using special characters, etc. But this will start by just define PD. You can see that it scrubbed it out. So now what we can do is come to change type. I'm going to select whole number instead. And one last thing to check, by the way, when you are, if you're converting text to numbers, this is a consideration to have anytime you do this, of whether or not you can set it to numbers or not. If I have any leading zeros that start into here, which I believe I don't, I can triple check. I think we're good. So in this case, that means that we can now set this to an actual number type. But so things such as zip code, which sometimes start with a 0, those are going to be instances where you would actually want to keep it as text because you cut off the leading 0 if you were to convert it to a number. So product key though is going to be good. It starts from 1 and it moves up. So we are going to convert that to a whole number. We're going to replace the value there. Beautiful. Good to go. All right. So that's one other thing that we can do. And I would also recommend a replace value, and that is going to be renamed to removed key from product. There we go. So I like to leave myself little breadcrumb notes throughout this. One other just mention too, if you want to leave an extra note on why you might have done this, if you right click and select properties, you have a description option, and I removed this to convert PD key to number. So I type a note into there explaining what I did, and you get a little symbol right here, plus the tooltip that pops up. So I'll say, like, you know, very honestly, I am one of the many people who probably does not like to take notes a ton. This is my way around that. If I rename the column steps appropriately, and then if it needs to have it, also indicate through a little tooltip maybe what my best practices are, those go a long way for me to help me kind of tune up my my queries, and to ensure if I come back to look at this in 6 months, I know what I did because I left myself a note. So that way I don't have to go document it in OneNote or PowerPoint or anywhere else. Okay, so we've done that. We've been able to change the type. Now another thing that we can do with a few of these in here, let's take a look through the rest of our data. Getting through a lot of this, we can see actually a couple things into here that we want to consider. One, let's take a look. We have date time here, and we have date key over here on the left. Now we have two date columns. Very commonly in SQL, you'll often get things like this, where you have a key and a date column itself. Now in Power BI, very commonly, what you usually key off of is an actual date data type column. But two considerations. So number one, we don't need this extra column. We can come back to the remove other column step. Let's go ahead and get rid of the date key. So removing duplicate or unnecessary columns that you will not use is a good practice. Another thing, yep, see, there you go. So there's an example. When you remove a column, it can potentially impact queries that are dependent from it down the line. So it's saying that the column date key cannot be found because it's attempting now to make that a numerical data type. So to fix this, you can either delete that and redo the step, or you can edit just a little bit of M code, come here to the top, and fix it there. It would be nice if you could like configure the change type somehow with a UI, but at least it's not too hard to like understand how the code's written at the top. Each column has a name and then a defined type with a comma and a curly bracket. So you can remove or edit that fairly easily as needed. So we've accommodated that. Now, taking a look again, here's another very common pitfall that I see people experience with data types in a model as well. So very often people will import a date time field that's coming from their database. Now thinking about this in terms of granularity, date time has a lot more unique values, like thousands, hundreds of thousands of more unique values, if not millions of more than date does, because you have every second of every minute of every hour of every day. And most of the time, people aren't reporting at that level. They are usually reporting sales per day or other stuff. And there are exceptions. I know some people who do report, like, per hour how much something is happening, but it is typically at a day level for most reports that I've built. So because of that, you don't need to import date time into there, because look at all these unique values you get into here. Otherwise, it would be a lot more recommended to reduce the granularity there up to something better. And I'm actually realizing now we're finally getting that column distribution that's showing up for some reason. So at least thumbs up for that. So let's go ahead and change this. So you might think, excuse me, that you can just simply change it to date. But let's see what happens if I do that. I just want it to be set as date only. You get an error message. Let's look at the error message. So it can't actually, by default, it can't convert this entire string to a date. It does not have the ability to parse out and grab just the date from there. It has to be kind of a two-step process. I wish it was one, but let me show you the proper way to do this. So because it is a date time, it does need to initially come through as a date time, but then what you can do is you can right click on it, transform, and extract the date only. That will add a new step, take out the date, and now look at the distinct values. 1,000 unique, 142 unique. So it has gone down quite a bit and allowed us to reduce the granularity, and it's going to reduce the footprint on our file size quite a lot. So again, only bring in the data at the level that is needed, so you don't have to unnecessarily burden the model and require the calculation to work through more unique values. So a great way to, again, kind of roll that information back up. A couple of other considerations we'll look through here as well. So with date, oh yeah, and probably also a good idea to rename that. So I'll double click. It's now date. There we go. Couple of other date considerations. So if you're applying date filters, again, pretty rarely, well, I wouldn't say rarely, but there's many scenarios when you would want to add some kind of a date filter onto here. So in this case, if you hit the drop down, you can come to date filters, and you have actually a lot of options for relative. So I'm going to do custom. If none of these work for you in the next or previous, you can come to custom filter. And let's say that I wanted to have in the previous, let's do like, because the date is a little bit older, I'll say like 15 years. And is in year, this year. So it's a two-step process, and it's OR, very important. So last trailing 15 years is in the current year. So now I've limited the window, because every time this, this is a relative date period, every time this refreshes, the date period will change. But I've now restricted to the rows needed into the model. So I very often will recommend applying some kind of a relative date filter if they have the option when dealing with dates as well. So there's an example of a relative date filter in here. I'm going to go ahead and rename that filtered to last trailing 15. There we are. And then one other kind of just example, just to showcase the filters and how they change, is maybe in this case, like, I probably only care about that load. Normally it's a little faster than this, but I feel like the demo gods always slow things down a little bit when you're in the middle of a demonstration. There we go. So let's assume that I just didn't care about a few promotions. So you can then also filter them out of there. And those are examples of a categorical, let's assume, and a date filter that can be applied. So filtered promotion. Examples for that. Getting close to the end of kind of the row and column modifications that I've talked about. The last thing that I want to mention, one more thing about granularity, is examples like this. So anytime you have usually $1 sales value, you typically want to set this not as decimal. What you would want to set this as instead is going to be fixed decimal number. That rounds at the 5th decimal, which is as far out as financial statements go, or the finance industry works with any kind of numbers like this. So fixed decimal will remove that, replace current, there you go. And we still have 1,000 unique values, but it at least increases the likelihood that there will be some repeating values now that it's being rounded closer, and it is just going to require less storage to save. The less decimals you have, the less file sizes there. So anytime you're dealing with information that does not need to go out to infinity with the decimal points, it's a good recommendation to put it as fixed because it just auto rounds it to there. If you need it additionally rounded up, and it is kind of annoying, I would say, by the way. So right now, it is displaying 2 decimal points for you. It is technically stored at the 5th decimal. It is misleading because you might think there's just 2 decimals being imported. So I've actually emailed the product team kind of a couple comments about this, just because it is not it's not intuitive, because you would think, oh, it has 2 decimals, that is what's being imported. So I personally think it's a bug, not a feature. But I have discussed with them to make it more transparent how many decimals are coming in. But if you truly needed to actually truncate or round this to just the 2nd decimal point, you have a couple of options up here to be able to apply rounding to round down, or to as well round to the nearest decimal places if you wanted to fix that and actually hard code it in to, again, reduce the granularity of your data as needed. So options available for all of that. Now, feel free to drop questions as you have any in the chat, but otherwise what I'll do is I'll kind of move on to my next section and then talk about some other techniques as well. I'll do a little quick recap before I do that. So okay, some recommended practices that we talked about. Selecting the columns versus removing. So selecting all in the columns that meet those current requirements. Filtering rows when possible, applying a relative dates filter for the history or any kind of a subset of the source data, be a category. Reducing granularity, if you can, on a column such as date time, probably the most common one. Getting that to a date level, reducing that data out, removing the number of unnecessary decimals that you have in a lot of the data sets too, will really help to ensure that that column comes in at a much smaller footprint, and then properly ensuring that those data types are configured. So kind of a nice little summary of those. Again, this deck will be available. There is also going to be some Microsoft Docs that will be able to help you with some of these other questions, but these will all be available as part of that PDF that I will have available for download. And like I said, if there are any questions, feel free to drop those into the chat. Otherwise, what I want to do is go to the next one as well, talking about optimizing query performance as well. And this one will be largely demo driven since it's more technical and less high level than the other ones. So we'll just go ahead and dive into a demo on that. Let me get up my reports. There we are. We're going to now talk about optimization and performance. So 2 different important differences between those. Optimization doesn't have to be just faster. It can also be fixed and consolidated. So both with Power Query and Power BI, my recommendation when you're getting started with this is that the first and most important step is it correct? So is the table structure correct when you import it? That's the number one thing you need to do. Secondly is optimizing it, getting it faster, simpler. Same thing in Power BI. Are your visuals giving you the right numbers? Is the information correct? If that's the case, that's the first thing you need to care about. Afterwards, then you can worry about tuning the visuals, making it faster, optimizing the report to a better version of itself. But that always comes as a phase 2. So here is an example where probably some of the most common pitfalls that I see people experience in Power BI really is having a lot of extra unnecessary applied steps. The 2 most common ones that I see are lots of renaming and remove. So they remove a column, removed a column, 1, 2, 3, 4 different renames, tons of change types. So they just go back and forth and back and forth. And technically, yes, the table structure that you have at the end is the correct structure, but it is many unnecessary extra steps to do all of these processes. So the goal to work towards a lot of this really is what I try to recommend is do most of those at the very end. So one of the first initial steps you want to do is get rid of all the extra unnecessary columns you don't need using the remove column step. Sorry, you removed other column steps. So that would be basically choosing your columns. And that can, just as a recap, that can be done one of two ways. I can either come here and I can say remove other columns, and that'll add a step called remove other columns, but it will do the exact same function as selecting choose columns, which also gives you an option to choose columns. So both steps are functionally identical. They just have different names. It just depends on how you want to navigate. So it's like, do you prefer to select the columns and remove everything else? Do you prefer to come up here and choose? They both give you the same result, but it's like two paths, just depending on how you want to use the interface. So that's kind of a step one. And then the rest of them, as I mentioned, is change types, and the renames really should be kind of kicked down the road. They should be placed at the very end of your query, so that way you can avoid all these extra redundancies and kind of repeating them over and over and over and over. So in those two scenarios, you can clean up your steps and reduce it, because the less steps that you have, probably the faster it's going to be, because it doesn't have to repeat itself. And then it's also just easier to debug or fix if you have all these listed over here. You don't have to worry about diagnosing 15 or 20 different steps. Now you can really just worry about 3 to 5. I kind of created an artificial example here, but you can at least see the idea of trying to avoid those. And if you start seeing the same step with a number next to it, that might be a consideration of whether or not it's an unnecessary extra step. If you see a change type 4, ask yourself, well, do I really need them in separate spots, or is there a way for me to maybe copy some of this and combine them? Could I do the logic for this step on one of the later steps or one of the earlier steps? So just ask yourself if there's ways to consolidate these. Okay. Another couple ones that I'm going to discuss here, is the idea behind a few things. So two items that are very beneficial to having very early on in your queries are filters and column removals, especially when you're dealing with a local data source. So if you import extra unnecessary columns and go through a whole lot of transformations, it still has to load the data from those extra columns before they get removed. So it will actually slow your model and slow your refresh down quite a bit when you do this. In an example here, very good to remove the unused columns early, because what that will do is that will ensure, if I can draw it here, that will ensure all steps below it. There you go. These will all run faster because there's less data to load in memory to pull this in and transform it. It's not really as important against SQL databases, because there are other optimizations we'll talk about later, but at least for flat files, it could be a huge performance impact to choose your columns first before doing the rest of the transformations, because you've now shrunk the size of the data. You've made it narrower to have to pull in, and that's going to be less size and less memory to fetch that data to apply your additional transformations. Another important one that is nearly universal as well is you want to move your filter step as early as possible. Again, if you filter your data early, all the subsequent steps that follow after it have to crunch less data to be able to do whatever is necessary for them. So that will also do a performance increase. So removing columns as a takeaway here, and filtering your data as early as possible will ensure that the rest of your query, regardless of where the data source is, both of these will help just to make it run faster and run into less performance issues related to both of this. Okay. A couple of other ones that we're going to talk about as well. This is actually something that I was told by Ken Pulse over who does the Excel Guru website. He is part of School. He's literally written a couple books on Power Query, and this was a little trick that he taught me a few years ago on optimization for adding a column. So there is a great, and I would say intuitive, column add called conditional columns. that lets you come in, add a series of steps, and I can, if channel key equals 1, that's let's call that online. Channel key, like you can set up some identifier column in here and add that to the model. Now this is actually it's not a super fast process to add this. And here's this example. We have store, online, catalog, reseller. So it can sometimes have a performance impact because it has to scan and iterate row over row, and it's not a very optimized poll for this if you add it this way. If you are hitting performance impacts, you're trying to fine tune a way to increase the size, increase the speed for this stuff. What I would recommend probably is instead doing a join column. So if you have a table that you can merge together with this, so here's my channel key and my channel name. So instead of doing a conditional column, if I did something instead where I merged the two together, so I did this, by the way, by coming up to the home ribbon, and I selected merge queries. I can do channel key, channel table, which lets me pull in my channel name. I can join based off of these two relationships. Let's see if it actually loads this pretty quickly or not. So it will usually show you the matches as well, but it is pulling from local files, so sometimes that takes a bit. So I'll give it about 10 seconds or so. Otherwise, I'll just click OK. But it is kind of nice to at least see the preview if it's a fast load. There we go. So yeah, it's like 900,000 rows, but it matched all of them. So at least we can confirm the keys are working. Doing that and then just choosing to then expand the column, which is exactly what I did. I selected this. I expanded channel name here, and then that pulled this in. So this is incredibly more efficient to pull in than adding the conditional column. So in scenarios where you might need to add a new column based off of a set of conditions and you're using that add conditional column option, consider if there is that table somewhere that you can either build yourself or join, and that will actually be an optimized way to pull the data in. So consideration on two paths to add the same data. It looks and smells the same, but they have different performance considerations as you are pulling them in. It's about 7:02 now. So there's a couple of other things that I want to show. And I think what I'm going to do is I'll circumvent this one. I want to switch gears to talking about query folding a little bit, and then if we have time, do the error handling as well. So let me close out of this. There we are. Okay. And I want to pull up my slide. Perfect. Do a quick summary of our recommended practices, and we'll talk a bit about query folding. So query optimization practices, as we've discussed in the demo, you want to do row and column selection first, choosing the columns and filtering the rows before transformations to reduce the amount of information processed by the mashup engine. Avoiding duplicate applied steps, so try to avoid those change type and rename type duplications. Removing duplicates from the table as well, and then that's the one that we didn't get a chance to specifically cover, but otherwise then adding columns using left joins. We've seen that is a better version of conditional columns. And again, these notes and everything else will be part of the PDF download if you want to download that later. I heard a Teams ping, so let me admit that. Okay, perfect. There we go. So let's go ahead and I'll skip that one for now. Some references in here. Again, any questions if you have any, but otherwise what I will do is also go to the discussion around leveraging query folding. Now, let's talk about what this is. So query folding is the ability for the engine to be able to generate a query back to whatever it is at the data source. Now, this could be SQL, this could be Snowflake. Most relational data sources, it has the ability to do this. Think of it as a Rosetta Stone. For those not familiar with that, is the universal language translator. It allows you to basically take a command that's written like a view that is passed back to the source. It is the most efficient path to connect a table in import all of the raw data format versus the data source can pre-filter it and hand you this small, clean little subset of data. So there are also ways to figure out what steps are query folding and not. And there are some great new features coming out soon that has about like 6 different status indicators on the types of query folding that can occur. That this presentation, from a very high level, just know that it is queries run much, much faster. And I'm going to show you how to identify it. Language will support query folding, so that will typically be relational databases, OData feeds. As you can also probably imagine, is data blob and then websites. A couple of lists, so I'm not going to discuss every one for sake of wanting a demo, but this again will be available as part of the PDF. And here's some things that cannot be folded as well. I have been proven wrong about this top one, so using a custom SQL statement. By default, it does not fold. There is a configuration into it, and if any of you actually are curious about how to query fold against a custom SQL statement, ping me, and there's a video that I think Guy in a Cube did, which was a link to an article that Chris Webb wrote, but there is technically a way to do that. It just requires a little bit of editing of the M code. But otherwise, here's another just kind of list of common steps that cannot be folded. But let's see how it actually can be viewed. In Power BI Desktop, there's an option down here to view native query. So if you click that, and if it has an option to click, that means that step is being folded back to the original data source. In this example, if we open it up, we'll actually see the SQL statement that is being ran here that will actually display exactly what is being passed back to the system. So this is the example of the SQL view that's being calculated. So let's go ahead and kind of see that in action a little bit. There we go. Okay. So I want to give you an example of many of the different types of things that can be folded, so we can kind of see some of those. And then I think they'll just have enough time to do this. Open it up for a little bit of a Q&A here at the end. So what I will do is, let's go ahead and just come over to this section here and notice that all the way down at the end, all of these steps are being folded. So typically, as you build this out, what you will do is you will usually do a step, and then to ensure whether or not it's folding, you can right click and see if that is still highlighted or not. So I just want to show you what the final query looks like. So this is the SQL statement. Maybe I can make it a bit bigger. That is a SQL statement that is being generated. It's not a pretty statement. Like, I'm sure many of you who've written SQL could probably like, oh, I can write that a lot cleaner. And it's not the point of how it's not supposed to be readable. The goal is that it needs to be optimized for performance. And sometimes it can write a bit of a bad SQL statement. I've seen scenarios where the code is not good, but the vast majority of the time, it's pretty good at writing a fast SQL statement. And that's the only goal. As long as it's fast, it's fine. But it manages to do all of these steps. It can automatically apply dates. It can do merges. It's bringing in inner and outer joins, many different things that are being applied into here, all because of the commands that I've given it. So that's kind of a thing where as you add steps, like, all right, I brought in my product table. Is that foldable? Oh, you know what? That's actually breaking it. Do I need to? Now, let me give you an example of something that would break it so you can observe. I'm going to come in and where is the index column? Add column, here we go. I'm going to add an index column because this great example right here. Like, that breaks my query folding. I cannot click this anymore. The problem now is every other step after it breaks. So now that means that when this breaks my query folding, everything else now has to do that process in memory. So these all have to download the full set of data and then apply these transformations inside of Power BI. I cannot do it in the database anymore. So what you want to do, again, is like with query folding as far as you can. So in this case, you have to add this step here, or maybe do it at the very end. You can move your steps around, and the step that will break your folding should be as sure that every step before it can still be folded. So that means that now I get this completed given to me with no effort from Power BI's end, and then I can start doing the transformations that require the data to be imported and done into here. So it's a kind of a game of seeing how far I can progress this to work towards that. And there's want to do as well as I wrap up. So for a very long time, I used to think that inner joins were not foldable because a left join is something that would work without needing to expand. So let me give you an example. I'm going to duplicate this, and I want to show you what I mean. There we go. So just having a merge step with a left outer join. I didn't actually expand a column, but I did merge the data together. All of these other things, they still fold. I still have a query folding option. Now inner joins do not do that. So again, for a while I actually thought that inner joins were not a foldable, but an inner join, I very often use this as a way to filter my data. So if I have table A and table B, I want to filter table A by table B. Like let's just, I want to map the keys between them and use that as a filter process. So I would very typically come in and do a join between them. So do an inner join on product using my inner join option here, only matching rows. I don't need to import the column. There's no reason for me to actually add a column because my goal wasn't to bring in data from that table. It was simply just a filter based off of the matching keys from that table option. But then all of my subsequent steps after this as part of query folding would break. None of these would work, and not, as far as the folding. So I always assumed this just inner join was an incompatible query folding option. So the trick to this is you need to do an inner join, and then you have to expand a column. If you actually complete the process, and it's a little too technical to get into the details of why, it doesn't matter what column you bring in. As long as you complete the inner join by adding some column from that table that you did an inner join with, and then you can remove it later, there we go. It still query folds. So that is required for an inner join, is you have to both do a merge and do an inner join step with the table 2, and then you have to add one of those columns from there. It doesn't matter which one it is, because again, you can just remove it later. But as long as we'll continue to go. The pro tip, again, there was something that was not to work towards that final process. So something that I really liked as well. I'm going to go ahead and now that we're getting close to time, I will start to wrap up here. Got a couple of other slides that I wanted to talk about and recommended practice. So let me do that and finish the wrap up. All right, so I'll quickly summarize this just because I want to give you a few links. As whenever possible, you want to kick that query folding process down as far as you can down the list. That will ensure for optimized practices. Again, I'll make this PDF available for download here in just a few minutes. But the final thing that I want to at least provide to you today is some links and resources as well, and then also thank the sponsors that we had for the events. All of my presentations and events do have PDFs that are available on my site here. I can drop these links into the team chat, which I'm hoping goes to the general group, but we'll find out. Consulting services and a couple of online courses that I have also built as well can be available at any of these links. I also have a lot of get started and ready to go templates for Power BI for people learning The tool, wanting to get familiar with adding calendar tables, many good resources available for that. I do have a 30% discount code for SQL Start 2022, so that will get you a 30% discount off of anything from my site, valid for a month. If you like this content as well, I would highly encourage you to check out my YouTube channel. I do a video every week recorded, and I do a live stream every Friday, so lots of good information there. Plus, if you ever have any curiosities around any content that I've built, always feel free to drop me a LinkedIn chat. I'm happy to answer many of these questions. I want to go ahead and copy this out. And the last thing I'm going to put up as I paste over some of the links. So this is a blog sign up raffle. So as a thank you, if you scan the QR code here, it enters your name into a hat as a part of the sign up form, and you will be entered into winning a raffle, which is has a prize of an hour of consulting from me or somebody at my company, and you get a chance to ask an expert anything related to Power BI for about an hour or so. So if that's something that interests you and you want to put your name into there, please feel free to do that. Otherwise, what I'm doing right now is I'm grabbing my presentation links and I'm dropping that into the chat now. There, okay, that is needed. Excellent, perfect. So, but I want to thank you all for joining today and attending this. This has been fantastic, and I appreciate you taking the time out of your day to listen to some of the best practice and tips and tricks that I've had. So much obliged, and thank you for all of that, and I hope you enjoy the rest of the conference as well. So thank you.